So you're asked to decide, well, what function was it that was rotated around this region to find the given integrand. So what solid of revolution is being described here. Now you've got a couple choices. If you look all the way down, most of these look pretty similar, except E is looking kind of strange there. So maybe we'll just kind of leave that one to the end. But the remaining four are pretty similar in as much as it's some function that is bounded by 0 less than or equal to x less than or equal to 3. So that's going to be something like this. Now your choice is rotate around the x-axis or the y-axis. So if we're doing a shell method, then let's see. Rotating around the y-axis would result in what kind of a slice here? What kind of a slice are we going to take if we're assuming that we're taking and rotating around the y-axis? Yeah, you'd be taking a dx slice. So that would give you a dx. You can kind of eliminate this pretty quickly because if you're rotating around the x-axis, what would be different? What would be wrong about rotating around the x-axis? Why would this be looking wrong? What kind of a slice would you end up taking? A dy slice. So you can eliminate B and D right away because they result in a dy slice. All right, so let's get rid of those. And we're kind of getting rid of that one as well. So now it's down between these two, A and C. If we follow through on our calculation, remember the volume of one of these shells is really going to be the volume of a rectangle. We looked at that in the last video, so to kind of remind you here, it's going to be the volume of this rectangular solid, which comes from the circumference on the top, the height here, and then the thickness. The thickness for us is going to be our dx. So 2 pi r times the height, well, I'll call this the width, times the thickness. So for r, in this case, if I call this, say, x and y, what's that radius? What's that radial distance there for us in terms of r? How far are we going from here to here? Yeah, it's just a distance of x minus 0, or just x. So if that's an x, then this integrand has to represent 2 pi, integral of 2 pi times x times some function times dx. So if that function is going to get multiplied by 2 pi x, what is that telling us that f of x has to have been? Yeah, x times something gives you x to the 4th. And go ahead, what was that something?
X to the 3rd.
X to the 3rd. So 2 pi times x cubed dx. So our function here is x cubed, and that one's looking like example C there. So looking good on that one. I don't know. What are your thoughts? Do you want to just calculate one, or would you like a multiple guess one on a test too? I'd probably make you justify it, so it wouldn't be just a guess. Hey, yes, no, interested in that? That'd be a problem?
Yeah.
Yeah. Thumbs up on that. Okay. That's kind of. It's not. I have to think about that one. I've not put one on an exam like that before. Most of them have been stuff like this. Now, I guess, and I apologize, what was tricky about this one might be that people were looking here and here. This is just what happens when you rotate this around. That figure is going to come underneath the x-axis and continue to sweep up this volume. What kind of a slice am I going to take this time? Now we're rotating around the x-axis. So what slice do we take? A dy slice All right, good. So dy. So there's our dy slice. So that's our thickness, our dy. Our width, that's going to come from this distance here. And now that distance here, if we call this x and y, that distance here is going to be x minus 0. This point on the y-axis has to be x and 0. So the width is x minus 0, or just x. But there's a problem with that. What's our problem with that? How come I can't just use x there? How come I can't use just an x? Is it Brandon? No. Yes?
I'm not sure.
You're not sure? What's wrong with using just x? Anyone?
You're taking a dy slice. You need to use y.
Yeah. By taking a dy slice, that's screaming out you have to take and put everything in terms of the variable y. So if I was to replace x by something, what should I replace x by? What would you get if you solve for x here? Cube root of y. So y to the 1/3 power equals x. And that's what's going to go in here, is y to the 1/3 power. Now we're going to run into the same kind of a problem when we work with our volume here. Or excuse me, when we work with the 2 pi r. For the radius, that's again going to be this distance. Oh, actually, you know what? It's going to be this distance right here. It's going to be y. Y minus 0. This point is going to be x and 0. So your radius is going to be y minus 0. Because you remember you're rotating around this axis. So that's just y. Let's plug everything in and calculate the volume of this thing. So that's going to be volume of one shell is going to be 2 pi times y times the width, which is y to the 1/3 times dy. Or let's clean that up, 2 pi times y to the 4/3 dy. Nice. Nice. Last but not least, I need to figure out the actual volume of our solid of revolution. So I'm going to integrate. Let's take the 2 pi out in front. 2 pi. Amro, do me a favor. Tap the desk behind you. Yes. Is it Marlon? Marlon. Yeah, thanks, Marlon. What would be my limits of integration here, Marlon? Well, this point here would certainly be 2 and 8. But remember, we're taking a slice with respect to y. So you want to look at where this slice could be in terms of the y direction. Where could this slice be taken? What's the smallest value of y it can use? What's the largest? 0 to 8. Thank you. So 0 to 8 of y to the 4th over 3 dy. Let's just kind of jump to the happy ending there. That's going to be 3/7 y to the 7/3. 3/7 times this is going to be 14 pi over 3. Is that right? Did I get that wrong? 3, no, that's not quite right. Trying to do too much here. 2 pi times 0 to 8 of 3/7 times y to the 7/3. That's going to give me 6 pi over 7. So, yeah, 6 pi over 7. 0 to 8 of, let's see, y to the 7/3. 6 pi over 7 times, let's see, 8 to the 7/3 power is going to be 128. minus 0 so 6 times that, divide by 7. Somebody bang that out for me. What's 6 times 128? That's going to be 786?
768.
768. All right. So 768 pi over 7 is a final answer. Awesome. Thank you. Whew. All right. Not bad. Not bad. Comments on example G here? All right. I think that's it for this section.